cubic functions and their transformations. Yeah, let me hide it. So this is the topic for today, and you're not going to it. So first one ఏంటంటే ఈరోజు f of x equals to a0 plus a1x plus a2x square, and this is a general form of quadratic function. Okay, కొన్ని ఎగ్జాంపుల్స్ తీసుకుందాం. లైక్ లెట్స్ ఫ్రేమ్ సమ్ ఎగ్జాంపుల్స్. 3x square plus 4x plus 5x square minus 2 root 2x minus square plus 3x plus 5 by root 2. అలా చాలా ఎగ్జాంపుల్స్ క్రియేట్ చేసుకోవచ్చుగా. సో ద మెయిన్ ఏంటంటే ఇక్కడ would mostly deal with graphs of quadratic functions, కానీ మనకి లిటిల్ లైక్ మనకి ఇంకా జామెట్రీస్ లైక్ నెక్స్ట్ టాపిక్ నెక్స్ట్ టాపిక్ మేబీ అందులో జామెట్రికల్ కర్వ్స్లో పారాబోలా గురించి చాలా పెద్ద టాపిక్ ఉంటుంది. సో దట్స్ ఎ బిగ్ టాపిక్, బట్ ఎక్కడ మనం జస్ట్ గ్లిమ్స్ చేస్తున్నాం. ఓకేనా? సో బిఫోర్ గోయింగ్ ఇన్ టు గ్రాఫ్ ఒక చిన్న కాన్సెప్ట్ క్లియర్ చేద్దాం అనుకుంటున్నాను. ఏంటంటే సపోజ్ f of x ఈక్వల్స్ టు a0 ప్లస్ a1x ప్లస్ a2x స్క్వేర్ అని ఉంది. ఓకేనా? సో మీకు ఎప్పుడైనా అనిపించిందా, ఒక క్వాడ్రాటిక్ ఫంక్షన్ తీసుకుంటున్నప్పుడు వాట్ ఆర్ ద ప్రాపర్టీస్? లైక్ ఇఫ్ యూ సీ లైక్ సపోజ్ గ్రాఫ్ అనుకున్నాం, ఇలా సంథింగ్ ఇలా ఏదో ఉంది. ఓకేనా? సో ఇది ఫంక్షన్ ఆఫ్ ఎక్స్, ఇది ఎక్స్. సో ఇక్కడ ఒక అబ్జర్వ్ చేస్తే అబ్జర్వ్ చేస్తే ఇక్కడ దాని వాల్యూ ఏంటి? మినిమం. సో దిస్ ఈజ్ మినిమం ఎక్స్ అట్ దిస్ ఎక్స్, అండ్ దిస్ ఈజ్ ఎఫ్ మినిమం, అండ్ ఈ పాయింట్స్ దగ్గర ఎఫ్ ఆఫ్ ఎక్స్ ఏమైంది? 0. సో దీస్ ఆర్ జీరోస్. సో కూల్. అండ్ ఇప్పుడు మన ఫంక్షన్ తీసుకుంటే జీరోస్, ఐ థింక్ ఇదంతా క్లియర్ ఆల్మోస్ట్ అయిపోయి ఉంటుంది అనుకుంటున్నా. అంటే ఏంటంటే a0 ప్లస్ a1x ప్లస్ a2x స్క్వేర్ ఈక్వల్స్ టు 0. దట్ మీన్స్ ఎక్స్ వాల్యూ ఏంటి? ఐ థింక్ మీకు ఈ ఫార్ములా తెలుసు అనుకుంటున్నాను. మైనస్ బి ప్లస్ ఆర్ మైనస్ రూట్ ఓవర్ బి స్క్వేర్ మైనస్ 4ac by 2a. So in this case minus a1 plus or minus root over a1 square minus 4a0 a2 by 2a2. ఓకే, ఇది సింపుల్. కానీ నేను ఐ వాంట్ టు నో మోర్. లైక్ ఐ వాంట్ టు నో వేర్, ఎక్కడ ఇది జీరో, లైక్ జీరో అవ్వడం కాదు. సో ఎప్పుడైనా ఆలోచించారా లైక్ ఎఫ్ ఆఫ్ ఎక్స్ ఎక్కడ మినిమం అవుతుంది? ఇప్పుడే చెప్పాను కదా, ఎక్కడ మినిమం అవుతుంది. ఈ మినిమం ఫంక్షన్ అది ఫంక్షన్లో ఈ వాల్యూ దగ్గర మన మినిమం ఆఫ్ ఫంక్షన్ ఆఫ్ వస్తుంది. సో ఎప్పుడైనా ఆలోచించారా లైక్ హౌ టు ఫైండ్ ద మినిమం ఆఫ్ అ ఫంక్షన్? ఇఫ్ యూ పుట్ ఇట్ ఇన్ ఎ సింపుల్ వే, సపోజ్ x ప్లస్ 5 ఫంక్షన్ తీసుకుందాం. సో 5 స్లోప్ 1 అండ్ ఇట్ విల్ కమ్ సంథింగ్ లైక్ దిస్, రైట్? ఓకేనా? సో ఎక్కడ జీరో, బట్ ఇది కీప్ ఆన్ ఎక్స్టెండింగ్ అండ్ ఇట్ విల్ గో ఆన్ ఎక్స్టెండింగ్. సపోజ్ నేను ఇప్పుడు ఏమంటున్నానంటే ఫైండ్ మినిమం ఆఫ్ ఎక్స్ ప్లస్ 5 బిట్వీన్ -5, 5. సో ఇది మన క్వశ్చన్. లెట్స్ సాల్వ్ దిస్ క్వశ్చన్. సో మీ అందరికీ తెలుసు కదా, ఇఫ్ యూ ఆర్ coming completely new to it, I recommend to go back to first video. అదేంటంటే లీనియర్ ఫంక్షన్స్. అది చాలా క్లియర్గా ఎక్స్ప్లెయిన్ చేసాం, అండ్ అది మీరు తీసుకుంటే దిస్ విల్ బి లైక్ టూ మచ్ ఈజీ. ఓకే, సో what is this value? Anyone can say like, yeah, this will be 5 because this is a0, like a0 plus a1x in simple 5 plus 1 into x. So idi a0, idi minus a1 by a0, that means minus 1 by 5 equals to minus 0.2. Oh sorry, minus a0 by a1, right? Yeah, okay, minus a0 by a1, so that will become minus 5 by 1. So let me erase it. It will like confuse you a little bit. Yeah, so ఇది ఏంటి y axis. ఇంకా సింపుల్గా చెప్పాలంటే we can say right minus 5 plus 5 equals to 0, but let's make it like regular way, so it will become easy. So ఇదేంటి minus a1 a0 by a1, so a0 minus 5 by 1, so minus 5, ఈ వాల్యూ ఏంటి minus 5, అండ్ 5 దగ్గర ఇది 5, ఇక్కడ ఏంటి వాల్యూ minus 5, ఇది 5, 5 దగ్గర f of x వాల్యూ ఎంత ఉంటుంది 5 plus 5, so 10, ఎక్కడ ఎంత ఉంది 0, సో minus 5 దగ్గర ఎంత ఉంది 0 అండ్ 5 దగ్గర ఎంత ఉంది 10. సో ఇందులో మినిమం వాల్యూ ఏంటి, ఐ మీన్ యాక్చువల్లీ మైనస్ 5 ప్లస్ 5 స్క్వేర్ బ్రాకెట్స్ పెట్టుకుందాం, ఎందుకంటే నేను ఫంక్షన్స్లో క్లియర్గా ఎక్స్ప్లెయిన్ చేస్తాను డొమైన్ అండ్ రేంజ్ చెప్పేటప్పుడు. కానీ ఓకే, సింపుల్ మీనింగ్ ఏంటంటే ఇది ఇలా ఉందనుకోండి, సపోజ్ 1, 2 అన్నాం అంటే ఏంటంటే లైక్ దిస్ బ్రాకెట్స్ లైక్ హౌ టు సే సింపుల్ బ్రాకెట్స్, లెట్స్ సింపుల్ బ్రాకెట్స్ ఉంటే దట్ మీనింగ్ 1 and 2 ఇంక్లూడ్ చేయలేదు, అంటే ఏంటంటే 0.9999 వాట్ ఎవర్ టు 1.999 మధ్యలో నెంబర్సే తీసుకోవాలి. బట్ ఇఫ్ యూ పుట్ స్క్వేర్ బ్రాకెట్ దట్ మీన్స్ 1 and 2 ఆర్ ఇంక్లూడెడ్, అంటే 1, 2 మధ్యలో ఏ వాల్యూస్ అయినా ఉండొచ్చు, ఓకేనా. సో ఇక్కడ ఏంటి -5 to 5 మధ్యలో ఏ వాల్యూస్ అయినా ఉండొచ్చు, 0 వాల్యూ ఇక్కడేంటి ఇది మినిమం, అక్కడ ఇది మ్యాక్సిమం. సో f minimum equals to 10 at the rate x equals to -5, ఓకేనా. సో అది ఒక ఫంక్షన్కి మినిమం చాలా ఇంపార్టెంట్, అండ్ లీనియర్ ఫంక్షన్స్లో మినిమం అంత, ఐ మీన్ ఇఫ్ యూ సీ లీనియర్ ఫంక్షన్స్ అది ఎలా లైక్ ఇట్ ఈస్ గోయింగ్ సమ్వేర్ infinite to infinite whatever, it's a simple line, but if you go to complex curves the concept of minimum is too much important, and there is a concept called differentiation అనే కాన్సెప్ట్ ఉంటుంది. రైట్ నో అది ఇప్పటికి మేము ఇంకా చెప్పలేదు, అండ్ ఐ డోంట్ వాంట్ టు గో ఇన్ టు దట్ బై హార్ట్ వే లైక్ గివింగ్ సమ్ ఫార్ములాస్ అండ్ రిమెంబర్ ఫర్ నౌ, అండ్ ఫ్యూచర్లో ఎక్స్ప్లెయిన్ చేస్తానని చెప్పాలనుకోవట్లేదు. బట్ యా, that shouldn't stop us, right, to go forward with this concept. That's why I'm gonna begin with whatever, like let's do some manipulations to the function and let's find the minimum of a function. Okay, cool. Yeah, so మీరందరూ ఈపాటికి నాకు తెలిసి కంప్లీట్ స్క్వేర్స్ అనే కాన్సెప్ట్ వినుంటారు, బికాజ్ -b ప్లస్ ఆర్ మైనస్ రూట్ ఓవర్ b స్క్వేర్ -4ac/2a, ఈ ఫార్ములా డెరైవ్ చేయాలనుకుంటే వీ హ్యావ్ టు like do some manipulations. Indirectly it's simple manipulation, even if you don't remember the name also it's okay. Let's manipulate the function and let's try to find the minimum. That's it. So f of x equals to a0 plus a1x plus a2x square అనుకుందాం. సో ఇప్పుడు నేను ఏం చేస్తున్నానంటే a0 ప్లస్ a2 కామన్ తీస్తున్నాం, అంటే ఏంటంటే x స్క్వేర్ ప్లస్ a1 బై a2x. ఓకే, దట్స్ కూల్. అండ్ a0 ప్లస్ a2 ప్లస్ x స్క్వేర్, మీ అందరికీ తెలుసు కదా a ప్లస్ b హోల్ స్క్వేర్ అండ్ ఈక్వల్స్ టు a స్క్వేర్ ప్లస్ 2ab ప్లస్ b స్క్వేర్. ఐఎమ్ trying to make this into something like into a plus b whole square form. I'll explain why we are doing. Meanwhile, plus 2 into a1 by 2a2. So 2 పోయినా సేమే కదా, సో సిమిలర్. ప్లస్ ఇంకేం చేస్తున్నానంటే ఇక్కడ a1 plus 2a2 whole square. If you observe, yeah, this is indirectly b a1 by 2a2, that's why, and minus a1 by 2a2 whole square, and directly this value is 0, so it won't affect, but it will affect the form of the function. That's the like goodness of the mathematics, and the complete squares is the like basic thing to start with the manipulation of the functions. And yeah, okay, whatever. a0 plus a2 x plus a1 by 2a2 whole square. Here x equals to a1 by 2a2 equals to b, a b and b. okay, b square 2ab, okay, 2ba, okay, yeah, minus a1 square by 4a2 square. So ఇంకా కొంచెం like let's keep something, let's do more manipulations. a2 లోపల manipulate చేస్తున్నా అంటే ఏంటంటే x plus a1 by 2a2 whole square minus a1 square by 4a2 square into a2. డైరెక్ట్గా ఏమవుతుందంటే a2 into x plus a1 by 2a2 whole square minus plus a0 minus a1 square by 4a2, ఎందుకంటే a2 square a2. సో ఇప్పుడు మనకి ఏమొచ్చిందంటే a0 ప్లస్ a1x ప్లస్ a2x స్క్వేర్ ఇండైరెక్ట్గా ఎంత ఇక్కడ a2 into x plus a1 by 2a2 whole square plus a0 minus a1 square by 4a2. Okay, cool. So both equations are similar, right? Okay. So let's observe this function, whatever. Let me try to observe this function, whatever is there. ఇప్పుడు అక్కడ తీసుకుంటే నేను x ఈక్వల్స్ టు మైనస్ a1 బై 2a2 తీసుకుంటే ఈ హోల్ వాల్యూ ఏమవుతుంది 0, అండ్ ఇదే మిగులుతుంది. అండ్ ఇండైరెక్ట్లీ ఇఫ్ యూ అబ్జర్వ్ దట్ ఈస్ ద మోస్ట్ మినిమమ్ వాల్యూ యూ కెన్ గెట్ ఇట్. Understand, right? Because if you make it like, let's say this value is 1, and if you make it x equals to 0, even it's become a2 plus, like it is increasing the value itself. Until unless it is minus 1, it is becoming 0 and it is becoming minimum. So indirectly x minimum equals to minus a1 by 2a2 and f minimum equals to a0 minus a1 square by 4a2. This is the important result we should remember, and everything is like ekanunchi, everything will rotate on these things only. So for a quadratic function x minimum equals to anta minus a1 by 2a2. Slowly we will call this as vertex, but that is like most interesting part we'll discuss. Like vertex ikkada easy ga అనిపించవచ్చు, but if you go to geometry, like geometry, this is become one of the most important concept. Like there are too many concepts like latus rectum, and there are tangents you can draw. Like that part is little bit interesting and difficult also, which is good. So at this particular point, this is enough. Okay, yeah. And f min equals to a0 minus a1 square by 4a2. So without wasting a second, let's jump into graphs. So get a pen and paper and let's start graphs now. Okay, cool. Okay, yeah, let's try to plot our, like if you remember previous function, that is linear function, I always draw like this a0 and slope is a1 and it will come as minus a1 by a2. Like this is how we'll define or will denote quadratic function. Like that there are same parameters, like simple parameters that will define the quadratic function, and we're gonna do it now. Okay, cool. Yeah, okay, okay, I'll start like this. So let's graph f of x equals to a0 plus a1x plus a2x square. What I want to say is, like when x equals to 0, like x equals to 0, that becomes f of x equals to a0. So x equals to 0 దగ్గర ఎంత ఉంది f of x a0. Okay, that's cool. And minimum value x minimum ఎంత ఉంది minus a1 by minus a1 by 2a2. So x minimum value ఎంత, like somewhere here, x minimum equals to minus a1 by 2a2. Okay, and f minimum ఎంత గుర్తుందిగా మీకు a0 minus a1 square by 4a2 which is less than a0 because a0 నుంచి some number difference తీసుకుంటాం కదా. So somewhere let's say here it will occur as f minimum and this is x minimum and that's it. ఇది మీకు సింపుల్గా అర్థం అవ్వాలంటే లెట్స్ హోల్డ్ ఇట్ సమ్ అవుట్ హియర్. నేను ఇంకొకటి గ్రాఫ్ తీసుకుంటాను. ఏంటంటే లెట్స్ డ్రా ఎఫ్ ఆఫ్ ఎక్స్ ఈక్వల్స్ టు ఎక్స్ స్క్వేర్. అంటే ఏంటంటే ఎక్స్ వాల్యూ 0 అయితే ఎఫ్ ఆఫ్ ఎక్స్ వాల్యూ ఏమవుతుంది? సో ఇఫ్ ఎక్స్ ఈక్వల్స్ టు 0 ఎక్స్ స్క్వేర్ ఈక్వల్స్ టు 0, ఎక్స్ ఈక్వల్స్ టు 1 ఎక్స్ స్క్వేర్ ఈక్వల్స్ టు 1. ఓకే, ఎక్స్ ఈక్వల్స్ టు 2 ఎక్స్ స్క్వేర్ ఈక్వల్స్ టు 4. ఓకే, similarly x equals to minus 1 x square equals to 1. So it is here, and x equals to minus 2 x square equals to 4. Same. So if you draw like this, some shape is coming, right? This shape is called parabola. Okay, this is like quadratic function graph will look like parabola, and this shape is called parabola, and that's it. And if you observe here, at this point both are same. This is like, we can say this is symmetric curve, and that's it. That's the concept we need to try it. So indirectly the x min f min point, what you are seeing here is called vertex. And here ఇక్కడ తీసుకుంటే x square f of x అంటున్నా కదా, and directly ఏంటి 1x square plus 0x plus 0 అంటే ఏంటి a0 0 and a1 0 and a2 equals to 1. So అంటే ఏంటి x minimum ఏంటి minus a1 by 2a2, but 0 by 1 is 0 by 2 is 0, and f min equals to 0 minus a1 square 0 by 4a2, that is also 0. So both values ఏంటి 0 అంటే ఏంటి ఇక్కడ ఇది మన vertex. So at the point of vertex you have to draw a symmetric curve. That's it, simple. So you know, like this point and this point, right? Try to draw a parabola on this point. Okay, it should meet at a0 because at x equals to 0 f of x equals to a0, no? So x equals 0, that f of x should be 0, and just replicate here, like yeah, okay, this is bad idea I think, but okay, let me draw manually. Yeah, so I'll draw like same curve. So both are symmetric. Okay, so this is how we define a parabola general quadratic function. And yeah, so let's summarize this on a scale, and we're gonna repeat it on the steps, because graphic transformations, like transformations what we are gonna discuss, will look simple, but if you don't follow like particular summary of the graph definition, then it will become more difficult. So that's why if you see linear functions also, we define it as simple like this. So every time you're gonna derive it easily. So yeah, whatever. So let me summarize this graph again here. Okay, cool. So what you do first, parameter definition one is x min, sorry, okay, definition one is I have to draw a0 because f of x equals to a0 plus a1x plus a2x square at x equals to 0, f of 0 equals to a0. So evaluate ఏమైంది a0, that is you can say step 1. And x minimum ఎంత ఇది minus a1 by 2a2, and somewhere here let's say here, and this value is a0 minus a1 square by 4a2, and you have to draw simple like, yeah, one line and match this to shape a parabola. Sorry, this is a0, okay, and no, sorry. So this is how you will define a parabola, okay. So this is f of x a0 plus a1 x square plus a2 x square. 1, 2, 3, and this what we call as the vertex. Okay, cool. So without wasting a second, let's jump into uh, quadratic function transformations. Okay, yeah, okay, cool. So next things is basic uh, transformations of quadratic functions. Sorry. So these are the basic. Cool. These are the basic transformations here, and yeah, let's jump into transformation. Transformation 1, that is f of x is transforming to f of x plus or minus a, which is like vertical shift up or down by a units. Okay, cool. Okay, so from this, like this will look a little bit easier if you follow lecture, but if you go to the next topic you're gonna forget. So keep on practicing this one because this is too much important, and they have the common functions we'll see common JEE and MZ problems, so it's important. Okay, cool. Okay, and so again a0 and a0 minus a1 squared by 4a2 and minus a1 by 2a2, and so like this. I'm sorry about the shape. Okay, this is bad. Okay, so both are like, I don't know, like both are no symmetry about vertex point. Okay. Okay. Let me draw this somewhat clear numbers. Okay, I'm sorry about that. So this value is a0 minus a1 square by 4a2, and this is minus a1 by 2a2. Okay, let's say f of x equals to a0 plus a1 squared by a1, sorry, okay, a1x plus a2x squared, and let's take first one in this f of x plus a3, I mean vertical shift up, and that is a0 plus a1x plus a2x squared plus a3, directly a0 plus a3 plus a1x plus a2x squared. So I have to shift from vertex, that's not, sorry, vertex, from here. So this will become what? Okay, I'm sorry, it may become maybe a little bit upper, but this value is a0 plus a3, and if you see here it will add, right? A plus a3 will add, no? So let's add, like let's take some point here, but a1 and a2 are not changing. If you see, both are same, so that's why this value won't change. Low, it will shift from vertex. So somewhere here, let's say a naught plus a3 minus a1 square by 4a2 came. So now this is our new vertex, and same, like it will come like this. Sorry, yeah, okay. So somewhere it will go like this. So both are parabolas, and if you like try to find intersection, it won't intersection, because if you see here, ఒకటి ఇప్పుడు చెప్తున్నాను, స్ట్రైట్ లైన్లో తీసుకుంటే స్లోప్ ఎప్పుడు కాన్స్టెంట్గా ఉంటుంది, బట్ ఇన్ క్వాడ్రాటిక్ అండ్ క్యూబిక్ వాట్ ఎవర్ కాంప్లెక్స్ ఫంక్షన్స్, హియర్ ఇక్కడ ఒక స్లోప్ ఉంది, ఇక్కడ స్లోప్ ఉంది, ఇక్కడ ఇంకో స్లోప్ ఉంటుంది, ఇక్కడ ఇంకో స్లోప్ ఉంటుంది, బట్ the slope whatever these curves are doing won't change. So at this point this slope will be there, that's why it never meet. Okay, directly to the parallel, but in a different perspective it is parallel. So yeah, it is shifting vertically up. Cool. And yeah, I think I should draw perfect parabola and copy that look, whatever. And next thing is f of x minus a3 and a naught plus a1x plus a2x square minus a3, indirectly a naught minus a3 plus a1x plus a2x square. So same, ఇక్కడ a naught ఉండేది, it may be come here, let's say here, or maybe here if it is more. So okay, so it's not a naught minus a3, it's a naught minus a3. Let's say it came here. Okay, a naught minus a3, or if a naught is too much large then it may come here, but whatever. Yeah, let's say it came here. Okay, and or let's say it came here. Okay, a naught minus a3. Okay, and this won't change. And what is this value? A naught minus a3 minus a1 square by 4a2. So definitely it will come somewhere here, may come somewhere here. Yeah, okay, and let's say a naught minus a3 come here. There is issue because I'm not taking real values, but yeah, I think you are getting what I'm trying to say, because if you're increasing a3 it is going that much, so if you're decreasing a3 it should go a little bit low, that's why I'm saying. Okay, so let's say this is the vertex point, like this is where this point is lying on. So again I have to draw, I have to mix it with this, and yeah, so this is indirectly vertical down, sorry, vertical down by a3 units, which is like simple, right? I mean, vertical shift up or down is like a little bit simple. So yeah, that's what about transformation 2. Let's jump into this one, horizontal shift left and right. Okay, yeah, second one is f of x transfer to f of x plus r minus a. So indirectly this is ఏంటంటే horizontal shift left or right. And ఒకసారి లీనియర్ ఫంక్షన్ క్లాస్ అబ్జర్వ్ చేస్తే I already told you, like f of x plus a చేసినప్పుడు it is shifting horizontally left, and f of x minus a చేసినప్పుడు it is shifting horizontally right. So it's like opposite. I do not mix it, because f of x plus a చేసినప్పుడు generally people will think it should kept right, but in this context and in this manner it is coming left, and we proved it also, so don't get confused with that. But yeah, whatever, let's draw graph again. Okay, so ఇక్కడ పాయింట్ ఏంటంటే again a naught and minus a1 by 2a2 a0 minus a1 squared by 4a2. So this is what that function looks like, right? Okay, let me try to copy this function. It's irritating. Control C. Yeah, good. Okay. Yeah. Okay. So a0 minus a1 squared by 4a2. Okay, that's cool. Yeah. So let's go into it. F of x equals to a0 plus a1 square. Sorry, a1x plus a2x square, and f of x plus a3 equals to a0 plus a1 x plus a3 plus a2x plus a3 whole square. And I don't want to derive everything to prove it out where it will look like, but if you remember what we studied in linear functions, that is, so this is linear function, right? a1 a0 minus a1 by a0, and if you are doing there f of x plus a3, it is shifting horizontally left. So this is there, and this will become here. Okay, and become a0 plus a3. Sorry, yeah. So it will become a0 plus a1x plus a1 a3. So somewhere it will come a1 a3. I told you that time. So somewhere it will come like this, but slope is same. So slope is a1. It's a1 here. So it is shifting somewhere by a1 units here, because if you calculate it, it is minus a0 by a1 minus a1 a3 by a1. So it's become minus a0 by a1 minus a1. So sorry, minus, yeah, minus a0 by a1 minus a1. So it is coming somewhere into this. So indirectly we are shifting that to left. So this is like a map of where you can define, and because even if you forget also, uh, you can derive this easily and you can correlate this to our functions. So what we have to do, we have to shift this to simple, like we have to shift this to minus a3, and directly the vertex will becomes now a0. So it's already minus a1 by 2a2, and you have to add minus a3 extra, and fmin will stay same. That means fmin is already become a0 minus a1 square by 4a2. It won't change. And yeah, so it will come somewhere here. So this is what uh, f of x plus a3 will look like. Okay, because x plus a3 will shift it to the left. Okay, cool. And yeah, obviously f of x minus a3 will shift it to this, and yeah, so somewhere let's say minus a1 by a2 plus a3, somewhere it come like this. And yeah, again we, oh sorry, yeah, again it will come somewhere here, and this is f of x minus a3. That's it, shifting left and right, which will become, which will make things easier. Okay, okay, cool. And let's go to our third transformation, that is vertical stretcher compression. This is little bit, I mean, I don't know how to say, interesting, and have to think, not just follow blindly. Okay? That is, yeah. f of x. So this one, let's discuss this one. Okay, part one, f of x transferring into a f of x. That means no, like vertical stretch, vertical stretch up, or like vertical stretch up and vertical compression or stretch down. Okay, this concept is a little bit different and not a straightforward concept. That's why just see and learn from it. Okay. Okay, cool. Let's try a parabola with this. That means this means, oh, sorry, this is, let's say, a naught minus a1 by 2a2 somewhere. So this is a naught, and a naught minus a1 squared by 4a2. So it will meet here, and okay, this, I think I need to practice more with this. Okay, whatever. So it's coming like this. Okay. Okay. Let me take a reference of linear function with this. Okay. A naught, a1, and minus a naught by a1. And if you remember there, f of a3, f of x, we are hinging here. Like hinging means we are fixing there and rotating, right? So if you're, it will rotate up. So this is vertical stretch up, and that is vertical stretch on down. There we discuss it. Actually, this is both are theta. I'm not exaggerating. It will sometimes look like this, but whatever. It's okay. It is what it is. Okay, and take a different and okay. Actually, listen to me. I mean, I don't know. Like most of the books, this concept don't have. I don't see anywhere this concept. They'll directly say we are stretching it up. But if you observe a key thing here, it is hinging. But where? How it is hinging? Because it is hinging about x-axis. No, like if you observe clearly, it is hinging where the curve is meeting at the x-axis. Okay. I'm not saying where it meeting, but with the x-axis it is hinging. And if you observe here, there is no meeting point of x-axis. At simple say with x-axis, how it will hinge. This is where one of the most beautiful, like one of the most important concept that will come. And yeah, and I'm repeatedly saying this. I don't never seen in a textbook, but which I found like really, like fascinating. Maybe you can say. Uh, so just observe this area. I'm already saying again, this is not hinged about a point. This is hinged about a line. No, you can see this is a line where it is hinged. So now the real concept comes, because I'm already saying if this is hinged, you can rotate it. But if it is a line, actually take it as a rubber. Okay, now we can say rubber hinge. Okay, no, for all most of the functions we use rubber hinge term, and you can stretch it. No, you can squeeze it. No, you can rotate it, whatever you know. So that's what rubber hinge it looks like. And if you take rubber hinge, if you start it like this, and it will stretch it, right? Yeah. So that's where, like, let's say this what we call is rubber band or hinge. Okay, so this is a rubber stretchable member, and Now things are simple. Okay, let me try it on it, but just listen to this. I hope I explained you what you're thinking, and this is too much important to me. So I have to stretch this graph a3 f of x, how it will looks like, and we have to stretch it. Let's say somewhere it came out. I mean, you can find these values easily. It's just a simple math, but I'm trying to explain a different thing here. Now, it may be like the slopes shouldn't be same, it may be different, but the parabola is here and we are stretching, and it will look somewhere like this. Okay, so this is a3 f of x, how it will look, and which is really main important. And stretch it down, so somewhere here, and this is what minus a3 f of x will looks like. And I prefer you to stop here and revisit the video, because if you're not getting here, I tried to explain it clearly, but if you're not getting this, try to revisit. It's not like simple, it's not like a too difficult concept, but this is very important topic you have to remember. Okay, yeah, cool. Yeah, let's go to next graph. That is, sorry, next transformation. I know it's like horizontal stretch, I think. Yeah, it's f of x transferred to f of ax. Okay, yeah. So f of x is transferring to f of x. That is horizontal stretch. You know, left or right, you can say, instead of up or down. Okay. Okay. Yes, there is no like, it won't make sense if you say vertical stretch up or down, and directly you can say horizontal stretch left or right, and again it's left, right. It's not like right, left. Okay, same. That concept applies here. Okay, and let's trick graph. And yeah, simple. Parabola a naught. Oh, this is minus a1 by 2a2, and a naught minus a1 square by 4a2 somewhere here. Okay. Okay, so this is a naught plus a1x plus a2x square. Okay. Cool. Don't need this also. And yeah, now this is our area of concentration again. I think most of the people are getting what I'm going to do. Okay, so this our now rubber hinge or band. So first one is like, if you do f of a3x, so this is HL, horizontally stretch left, and f of minus a3x, that means horizontally stretch right. Okay, so adi ippudu, so this stretch it a bit, so along to this somewhere like this. And remember, these both are not same, it may change. Okay, it will stretch it. Okay, and if you go here, you know, this value we can find it. Let's try to find this, because we have to understand this one, right? So a naught plus a1 plus a2x square, so a naught plus a1 a3x plus a2 a3x whole square. Now a naught plus a1 a3x plus a2 a3 square x. So and directly what is happening is like this a naught is not changing. That's why we need to derive every time because we won't remember what exactly is happening. So yeah, um, so this is also like a naught is staying same. I mean a naught won't uh, change, that is no, that is actually good actually, because it makes sense also, because uh, this parabola is staying like this and you're stretching here. That means about y-axis it won't change. Like yeah, like we are stretching not only like this, but yeah, now think in this direction. Anyway, this will stretch, and the strong hold of y-axis is not change the value of a naught. And this is where things are important. So whatever, sorry, okay, so this graph is proven to be false. Okay, let me draw this again, whatever. So let me take a coordinate axis again. Yeah, actually I'm sorry for the people who already drawn it. Just make it false, or like, this is contradiction to the proof. Okay, okay. So somewhere it will come like this, and so this is a naught. Let's say this is minus a1 by 2. I'm gonna zoom it a bit, okay, which will make things easier. A naught minus a1 square by 4a2. This is our curve. So this is our rubber band, and slowly people got to know like a naught value is not changing. So f of a3x, how it will look like, means it will stretch somewhere here. No, okay, so let's say here, and okay, yeah, so it will stretch to the left, and it will look like this. Anybody have like if you have anybody doubt on this, uh, okay, yeah, and if you go to the, so this is f of a3x, and if you go to the f of minus a3x, somewhere it will come, and yeah, this is same. So this is f of minus a3x, how it will look like. Okay, so it's like stretching up and down, sorry, stretching left and right about, and a straight rubber band maybe like this. Okay, cool. Okay, so still how many are there? It's like, yeah, the last three are simple, so 5 6 7. Okay, so fifth one is a reflection about y-axis. Reflection about y-axis. Okay, draw a graph. I will complete this in 5 minutes, don't worry. So a naught minus a1 by 2a2, this is y-axis, so make it somewhere here and it will come like this. Okay, so this is how f of minus x will look like, and indirectly now this one. This is actually fascinating, like slowly if you go into the geometry concepts, this will help a lot. And if you go to JEE problems, I see most of the people don't have proper grasp on the graphs, and they are making too many mistakes on the graphs. Not even graphs, like if you want to understand the functions, or they have number of solution problems and all, అక్కడ కూడా చాలా issues create చేస్తుంది. That's why I started with graphs. Okay, no, like that is more no way into it. Yeah, and yeah, this lecture is about like free flow. It's like I didn't even prepare also, like I'm just going with the flow. Okay, yeah. And f of x minus f of x, reflection about x-axis. Reflection about x-axis. So take a graph. Let's extend a bit. Okay, cool. So yeah, come on, a0 minus a1 by 2a2 and a0 minus a1 square by 4a2, and okay, so sorry, little it's getting a little excited, but yeah, so it will look like this. And reflection about x-axis, this, 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 that's it. Okay, okay, so this is x-axis. Oh, cool. And the final transformation, 7. Now reflection about origin minus f of minus x. And I am saying again, for the people who don't know the concept of vertex and hinging, they are finding difficulty in simple reflections also, which surprised me a lot, which is like a basic and easy concept. Okay, so yeah, like going to the basics will help. Okay, this is minus f into f of minus f of minus x, so careful on this or whatever. And yeah, I think it's extending more than an hour, but yeah, I'll make it fast. Okay, so a0 minus a1 by 2a2. I'm sorry about the shapes again, but this is the vertex, and just take it a line maybe. Okay, yeah, I'm tired of like trying perfect shapes. So we are reflecting vertex about origin, and this is our vertex. And again, I hit like something. Oh, sorry about the shape, but somewhere it will look like this. Sorry, it's exactly same actually. It's just reflection. There is no stretch down here, and this is minus f of minus x, and that will conclude our quadratic functions. And okay, let me discuss a cubic function, in a way of like 8 minutes maybe. Okay, yeah, I know this. I won't not lag a bit. I'll explain in a simple way. Okay, cubic function f of x, and then the f of x equals to a0 plus a1x plus a2x square plus a3x cube. How it will look like, I'll just show. I don't want to show again, even if I don't, even if I have less time also, I don't want to look like remember this. I'll just draw for x cube and I'll explain you how to look like. Okay, so x cube x equals to 0, it's 0, x equals to 1, 1, x equals to 2, somewhere around 2 cube, so 1, 2 cube 8, so 3 cube 27, so 1 cube, sorry 8. Oh, clearly observe my and minus 1, no, minus 8, minus 1, so it's similar, like okay, draw in simple way. It is both are symmetric. Okay, this is how x cube function will look like. I don't know, like here it may be little deviated, but remember both are like no. Okay, both are like uh, okay, both are like I don't know, like somewhere it will look like this. Okay, this is somewhat deviating. Okay, so this is how it will look like. Don't worry, if you will try it for a generic function, there you will get it. Okay, so a naught, so this is like vertex point, you can say. Okay, so yeah, this is looking somewhat good. This is what a naught plus a1x plus a2x square plus a3x cube it will look like. Okay, and I'll derive the transformation here itself. So vertical stretch up and down, so a naught plus a3, no, a naught minus a3, so this is like f of x plus a3 and f of x minus a3 will look like. That's the advantage, like if you understand the concept, then it's no cakewalk. And yeah, people will curse me again on the hinging, but this hinging is easy, like I know, like that's what people will say, like for odd functions like x cube, x power 5, x power 7, the transformations are easy, but if you take even functions x square and those concepts, they are like not straightforward. You have to think in a way, because yeah, that's what it is. Okay, okay, a naught, okay, this is what a naught plus a1 x square. Look at the transformation mean. Okay, yeah, horizontal shift f of x plus a, so it's same, f of x plus a, same, both are same, don't worry. Okay, so this is f of x plus a4, now f of x minus a4. Okay, and next one is okay, vertical structure compression. Okay, so yeah, f of x or minus a f of x, which is like horizontal vertical stretch up or down. Again, it's have to take from x-axis where it's hinging and stretch it up, and yeah, that's it. Now it may not be same, it may extend also, but this is how it will look like. And stretch it down somewhere like this, somewhere it will stretch down on this way. So this is a3 f of x and this is minus a3 f of x. Okay, and f of plus or minus a3x, that is horizontal stretch left or right, same we'll draw for that, it's not a big deal. Okay, so this is where our non-linear function will help a bit, because there we are doing on the y-axis basis, right? So same, like now it's hinged about it here with the y-axis, so somewhere up and somewhere down. So this is f of a3x and this is f of a3x. So I told you, like, this is the advantage of no odd functions, odd powered functions, x cube, x power 5. Now this is like simple advantage of it, like you can write easily and not stretch it up, like not think that much. Okay, and yeah, I think you can draw these, right? It's like simple only. And yeah, I'm gonna end up this session because it's already late, and today we discussed too many things, I think, but not too many, but like, yeah, there are some concepts which you need to make some special interest, and they're just like, it's like, yeah, like, just don't by heart, like, just see how it's happening, and that's how you can understand, play with the graphs, and go to the next level concepts. Okay, yeah, have a good day, bye.